Hi, this is David Voss, CCIE 11372, and in this video you're going to learn about designing quality of service. Specifically, we're going to be going over the following categories of quality of service: classification, congestion management, link efficiency mechanisms, and then traffic shaping and policing. Now, it's obvious from the CCDA study materials that Cisco does not expect you to be an expert on quality of service. It is a huge topic. They just want you to understand the basics. So do not spend too much time digging into the intricacies of quality of service, because there will be time for that in your advanced studies. For now, let's talk about quality of service at a higher level, and then discuss the quality of service concepts that Cisco wants you to know for the CCDA exam. Quality of service is a tool for managing a WAN's available bandwidth. Now, quality of service does not add bandwidth, but it helps you make better use of what you have. If you have chronic congestion issues, quality of service should not be the primary answer to resolving that problem. You need to add more bandwidth. However, by prioritizing traffic using quality of service, you can make sure that your most critical traffic gets the best treatment and available bandwidth in times of congestion. One popular quality of service technique is to classify your traffic based on a specific protocol type or matching access list, and then giving a policy treatment to that specific class. You can define many classes to match or identify your most important traffic classes, for example, video or voice. And then the remaining unmatched traffic then uses a default class, which is the traffic that can be treated as best effort. So let's begin with classification. For a flow to have priority, it must first be identified and marked. Both of these tasks are referred to as classification. The following are popular technologies which support classification. NBAR, it's a technology that uses deep packet content inspection to identify network applications. So an advantage of NBAR is that it can recognize applications even when they do not use standard network ports. Also, it matches fields at the application layer. Before NBAR, classification was limited to layer 4 TCP and UDP port numbers, but NBAR has changed that. Next is CAR, committed access rate, and uses an ACL to set precedence and allows customization of the precedence assignment by the user, source or destination IP address, or even application type. Next, let's talk about congestion management. There are two types of output queues that are available on routers: hardware and software. The hardware queue simply uses FIFO, first in, first out. But the software queue schedules packets first and then places them in the hardware queue. Now keep in mind that the software queue is only used during periods of congestion. The software queue uses quality of service techniques such as priority queuing, custom queuing, weighted fair queuing, class-based weighted fair queuing, low latency queuing, and traffic shaping and policing. Let's go through each one of those. Cisco does not expect you to know each of these in detail. Again, that would be later in your CCDP studies. But that being said, they want you to understand what each of these are. Priority queuing is a queuing method that establishes 4 interface output queues that serve different priority levels, which are high, medium, default, and low. Unfortunately, priority queuing can starve other queues if too much data is in one queue, because higher priority queues must be emptied first before lower priority queues. Next, there is custom queuing. It uses up to 16 individual output queues. Byte-sized limits are assigned to each queue so that when the limit is reached, it proceeds to the next queue. The network operator can customize these limits, and custom queuing is obviously fairer than priority queuing because it allows some level of service to all traffic, But this is really a legacy solution because there are improvements in the queuing methods, which we'll talk about next. Weighted fair queuing ensures that traffic is separated into individual flows or sessions without requiring that you define access lists. Weighted fair queuing uses two categories to group sessions: high and low bandwidth. Low bandwidth traffic has priority over high bandwidth traffic, and high bandwidth traffic shares the service according to assigned weight values. Please know that weighted fair queuing is the default quality of service mechanism on interfaces below 2 megabits per second. Next is class-based weighted fair queuing. It extends weighted fair queuing capabilities by providing support for modular user-defined traffic classes. Class-based weighted fair queuing lets you define traffic classes that correspond to match criteria, including ACLs, protocols, and input interfaces. Traffic that matches the class criteria belongs to that specific class, and each class has a defined queue that corresponds to an output interface. So after traffic has been matched and belongs to a specific class, you can modify its characteristics such as assigning bandwidth, maximum queue limit, and weight. As you see in the picture here, certain classes receive higher priority than other classes. As you see in the diagram here, certain classes receive more bandwidth than other classes. And also, as you see here, this is a form of class-based weighted fair queuing, but actually this is called low latency queuing because it has a priority queue. And that's the big difference. The strict priority queue allows delay-sensitive traffic, such as voice, to be sent first before other queues are serviced. That gives voice preferential treatment over other traffic types. Unlike priority queuing, low latency queuing provides for a maximum threshold on the priority queue, and this will prevent lower priority traffic from being starved by the priority queue. Now, without low latency queuing, class-based weighted fair queuing would not have a priority queue for real-time traffic. Now that we've talked about queuing, let's talk about traffic shaping and policing. Traffic shaping and policing are mechanisms that inspect traffic and then take action based on the traffic's characteristics, such as DSCP or IP precedence bits set in the IP header. Traffic shaping slows down the rate at which packets are sent out an interface by matching certain criteria. Traffic shaping uses a token bucket technique to release the packets into the output queue at a pre-configured rate. So this helps eliminate potential bottlenecks by throttling back the traffic rate at the source. Traffic shaping is used on larger networks to smooth the flow of traffic going out to the provider. This is desirable for a few reasons. In provider networks, it prevents the provider from dropping traffic that exceeds the contracted rate. Now, policing is a little bit different because it tags or drops traffic depending on the match criteria. Generally speaking, policing is used to set the limit of incoming traffic into an interface, and then it will drop traffic that exceeds what the settings were. One example of using policing is to give preferential treatment to critical application traffic by elevating to a higher class and reducing best effort traffic to a lower priority class. The best way to compare shaping with policing is to remember that shaping buffers packets. Policing does not. It can be configured to drop packets. Our final topic is link efficiency. Within Cisco IOS, there are several link efficiency mechanisms available, as you can see here. There's LFI, which is used to reduce delay or jitter on slower speed links. Multi-link PPP, which bonds multiple links together between two nodes, which can increase available bandwidth. And then RTP, real-time transport header compression, which provides increased efficiency for applications that take advantage of RTP on slower links. So here's what you've learned. You've received a high-level overview of quality of service, and then you learn about quality of service functions such as classification, congestion management, link efficiency mechanisms, and then traffic shaping and policing. If you know this video well, you'll do well on your QoS portion of your CCDA exam, and I wish you the best of luck in your studies.